So what we will discuss today, we will discuss what is the work input to the compressor in the single acting reciprocating compressor without clearance. So first we will discuss what is the PV diagram in the next class, in the previous class. So today we will discuss what is the theoretical PV diagram of single stage single acting reciprocating compressor without clearance. That will be shown here. You can see here. This is your point. This is your top dead center TDC. Though we are not considering any clearance, so this one is your top dead center, this one is your what? This is your bottom dead center. When the piston move from TDC to BDC, the atmospheric air will be entered into the cylinder with a volume what? With a volume of V1. So when the piston move from TDC to BDC, the volume covered by the piston, that is known as your what? Zero volume. So you can say V1 is your what? V1 is your Vs. You can consider V1 is your hot pot, V1 is your Vs. Yeah. So A to 1 is your suction and 1 to 2 is your compression. Here we are considering PV to the power n is equal to constant name. That we are considering polytropic compression. Then 2 to B is your deluge. And B to C, there is no air inside the cylinder because we are not considering the clearance volume. So the no air will return from B to C. Okay. So basically your PV diagram is your A to 1, 1 to 2, 2 to B and B to A. So to calculate the work done, work input to the compressor. So we know that area under PV diagram, this is your pressure, the pressure and volume diagram. This is your pressure and this is your volume. So area under PV diagram will be give us what? It will be gives us work done. I don't know. Area under PV diagram will be gives us work done. Okay. So you can calculate this area. A to 1, 1 to 2, 2 to B, B to A. This area if you are calculating, then we can get the work done. Okay. So we have to separate all the process. Then A to 1. So here I am. You can draw a line that is given as C point. Here are 2 points from a given line that is the D point. So we are separating all the process. That is A to 1, 1 A to 1, 1 to C, C to O, O to A. That is the one area. Then considering 1 to 2 process, that polytropic process, we consider 1 to 2, 2 to D, D to C, one area. Then 2 to B, that is your 2 to B, B to O, O to D, D to 2, that is area. So, suppose this is your 2 to B area, this is your 1 to 2 area, and this is your A to 1 area. So, if I see that in the 2 to B area plus 1 to 2 area, you see, this is your 2 to B area, 2 to B, B to O, O to D, D to 2, plus 1 to 2, 2 to D, D to C, C to 1. If I add this area, and if I minus this area, which area? A to 1, 1 to C, C to O, O to A. Then we got which area? We got area under 1 to 2, 2 to B, B to A and A to 1. Is that clear? So, to calculate this one, so I separate all the process A to 1 process. So, A to 1 process if I separate, this is your A to 1. A to 1 area under A to 1 is your A to 1, 1 to C, C to O, O to A. What is the pressure here? Pressure is your P1. What is the volume? V1. So if I consider the 1 to 2 process, that is a polytropic process. 1 to 2, 2 to D, D to C, C to 1. Okay. That is your second process for polytropic process area. Then third one, 2 to B. And 2 to B, B to O, O to D. So what is the volume here? V2. What is the pressure here? V2. Okay. So what we have to do? We have to add 1 to 2 process area plus 2 to B process area, and we have to minus of what? We have to minus A to 1 process. So you can see here in the A to 1 process, area under PV diagram will be gives us what? Work done. So area under PV diagram. So see A to 1, 1 to C, C to O, O to A. This area will be looking at what? It will be looking at a rectangular section. For a rectangular section, what is the area? Length into breadth. So what is the length? P1 and V1. Length into breadth means length is your P1 and breadth is your length is your P1, breadth is your P1. So we can say the work done at here, this area will be what? P1 and P1. Yes or no? So polytropic process that you know, P1 B1 minus P2 B2. P1 V1 minus P2 V2 by n minus 1. That is the what? Area under polytropic process. Okay. So if you see the 2 to B, so this is also 2 to B, B to O, O to D, D to 2. So it is also seen as a rectangular section. We can say about the rectangular section, that is your P2 into V2, edge length into breadth. Also you can put 2 to B is your constant, which process? Constant pressure process. You can put here constant pressure process. What is your work done? P into initial final volume minus initial volume. You can also put. So here initial volume is what? 0. कोई volume नहीं है initial. Final volume is your what? V2. So here pressure is your P2. So P2 into V2 also you can put here. Here also A to 1 is your constant pressure process. For A to 1, you can say for constant pressure, what is the work done? P into final volume minus initial volume. Final volume minus initial volume. So what is your initial volume here? Well, there is no volume means clearance volume are considered. So initial volume is 0. Then what is your pressure here? P1. What is the final volume? That is your P1. So P1 V1, that is also work done. For what? A to 1 process. Then 1 to 2 process work done, that you know P1 V1 minus P2 V2 by n minus 1. Okay. So what you have to do? Basically you have to add 1 to 2 process area plus 2 to B process area and minus of what? Minus of A to 1 process area. See here, 1 to 2 process area, this area, minus 2 to B process area, minus plus 2 to B process area, minus of what? Minus of A to 1 process area. So that we got the process of A to 1, 1 to 2, 2 to B, B to. Clear? See, we have to find out the indicator work done on the air per cycle. So what you have to area under A to 1, हमें क्या निकालना है कौन सा एरिया देखो एरिया अंडर A to 1 1 to 2 2 to B B to A so that you have to calculate so for that what you have to do you have to add 1 to 2 2 to D D to C plus 2 to B D to O O to D minus of A to 1 so see here so what you are doing area under 2 to B means what tell discharge upon 2 to B B to O O to D, D to T and area under C to 1, 1 to 2 process. Minus of what? Minus of A to 1 process. That you have to minus. So area under 2 to B, that is your what? That is your P2 into V2. And with the area under 1 to 2 process, that polytropic process is P2 V2 minus P1 V1 by n minus 1. Why it will be? Because compressor is a negative 4. So that is your P2 V2 minus P1 V1 by n minus 1. Minus of area under A to 1 is your what? Area under A to 1 is your P1 V1. So if I arrange this one, P2 V2 minus P1 are kept in one side, plus of P2 V2 minus P1 by n minus 1. So now you can see here P2 V2 minus P1 and here P2 V2 minus P1 V1. So I am taking common, so what is left? 1 plus 1 by n minus 1. Okay. Then if I am taking the LCM, then n minus 1, here n minus 1 plus 1 minus 1 will be cancelled. What is left? N by n minus 1. So n by n minus 1, P2 V2 minus P1 V1. That is the work input to the compressor. N by n minus 1, P2 V2 minus P1 V1, that is kilojoule per cycle. That is your what? That is the work input to the compressor. Clear? So if I rearrange this equation, so in other air is the ideal gas, so you can put here PV is equal to MRT, ideal gas characteristic gas equation. So for P1 V1 we can put MART1, P2 V2 MART2. So if you put then equation 1 become this equation 1. Yeah, equation 1 become in place of your P2 P2 we put MART2, P1 V1 we put MART1. Okay. So MART2 minus MART1, so A mass of air into R, that will be taking common. So what is left? T2 minus T1. Yeah, that is the one formula. N by n minus 1 mass of air into characteristic gas constant into final temperature minus initial temperature, unit is your kilojoule per cycle. Then if you are taking the T1 common, what is left? T2 by T1 minus 1. So though 1 to 2 is a polytropic process, then what is the relationship between temperature pressure? We know that T2 by T1 is equal to P2 by P1 to the power n minus 1 by n. So in place of a T2 by T1, what you can put? P2 by P1 to the power n minus 1 by n minus 1. Okay. So that is the formula. Next. So where n, what is the n? N is your polytropic index. What is your P1? Intake pressure, P2 delivery pressure, P2 by P1, that is your pressure ratio here P2 by P2 by P1, that is the pressure ratio, Ma is your mass of air in kg, R is your characteristic gas equation, and V1 is your intake volume, V2 is your volume after compression. You know that V1 is equal to Vc, that is pi by 4, V1 is equal to Vs, that is your pi by 4, D square, that is your circle. Okay, so see here, what is the formula? W work input is equal to N by N minus 1 MAR, T2 minus T1 in kilojoule per kg. Is that clear? So then what is the formula for work done? That is kilojoule. So in place of your MA, so if I put here work input is equal to N by N minus 1 mass flow rate of air M dot A, mass flow rate of air into R, characteristic gas constant into T2 minus T1, then what is the unit? The unit becomes kilowatt. And this will not be the work input, this will become the indicated power. So what is the unit of kilowatt? Kilowatt is the, that is our unit. So that becomes indicator power. In case of if in place of your mass of air, if you put mass flow rate of air M dot A, then it becomes kilowatt. That is the power. Okay. So that is the what? If we are considering the polytropic compression. So next we will discuss if we consider the isothermal compression, then what will be the work input. Same that we have to add a 1 to 2 area under 1 to 2 plus area under 2 to B minus of area under A to 1. Okay. Then we will got the work done. So next class we will